Now we'll be talking about pipes and cisterns. Pipes and cisterns is nothing but an extension of what we've already done in the concepts of time and work in the chapter time and work. So there are like this theory portion which I'm going to talk about. This is just a very small prerequisite. You must understand about it. The only difference is that in time or in time and work, most of the work that was being done was positive work, and hardly nobody was there who was destroying work. Okay, everybody was doing only positive work. But in pipes and cisterns, there is a concept of destroying work. Why? Because if there is a jar, let's assume that this is a jar which needs to be filled, right? This is a jar which needs to be filled, and I'll be using one pipe which is pouring water in. So when water is being poured in, it is a positive work. And let's assume there is a hole at the bottom which is releasing water. Okay, this is releasing water. So this is nothing but negative work. This is nothing but negative work. So this is the only concept which you need to understand. Everything about time and work which we were doing, that we were following the LCM method to take out the answer. So everything is going to remain the same. I'll quickly make you go through the theories, and then we'll be quickly solving all the questions. Pipes and cisterns problems usually consist of a cistern and tank to which one or more pipes are connected or filled, and some of them empty it. Okay, these are similar to time and work problems. I've already talked about this. In these problems, the work can be positive when the tank is being filled and negative when the tank is being emptied. And there are a few direct formulas. If a pipe can fill a tank, then 1 by x of the part of the tank is filled in 1 hour. This is the same way. Let's assume that it takes 10 hours for anybody to do the job, for A to complete the job. Then in 1 hour, 1/10 of the job would be complete. Okay, 1/10 of the job will be complete. This is the same point. If one pipe can fill the tank in x hours and the other can fill the same tank in y hours, the same formula of LCM, doing the LCM, right? X and y, then xy is the LCM. The efficiency is y over here, the efficiency is x over here. The total time it's going to take is xy whole upon x plus y, right? Then one pipe can fill a tank in x hours, but another pipe can empty. When we talk about emptying the pipes, or one of the pipe being the emptying pipe, will, instead of having plus over here, we would have minus over here. Okay, if the net result comes out to be negative, that means the tank was emptied. Okay, the tank was emptied and not being filled, right? So we have everything in place. We'll quickly move to the questions now. Okay. Two pipes A and B are filling an empty tank in 15 hours and 18 hours. Both pipes are open simultaneously to fill the tank. How many hours will the empty tank be filled? Okay. So let's assume the first pipe is A, the second pipe is B. It's going to take plus 15 hours to fill the tank and plus 18 hours to fill the tank. Together, we have to find out the LCM. 15 and 18. I think 90 is the LCM, because in the table of 15, 15 6 are 90 and 18 5s are 90, right? So this is going to be plus of 6 and this is going to be plus of 5. So my final answer would be, my total work is 90 and 6 plus 5, which is equal to 90 upon 11, and 8 2 by 11 is going to be my answer. Okay, 8 2 by 11 is my answer. I don't think it was very tough. We've already done it in time and work, and this is just an extension, just an application of it. Okay, moving on. Okay, yeah, I'll just remove this. I had just solved it for my own convenience. Okay, 5 pipes are required to fill a tank in 1 hour and 40 minutes. How long will it take to fill the same tank if four pipes of the same type are used? We are going to use the same formula. MDH is equal to MDH. Here, man is nothing but pipes. Okay, pipes. So 5 pipes are required, and 1 hour 40 minutes. 1 hour 40 minutes, I would convert it quickly into minutes. 60 minutes plus 40 minutes. This gives me 100 minutes. Okay, so 5 into 100 is the work being done. Now the next side or the right hand side of the things, the same tank is being used, so the work being done on the both the sides would be the same. So four pipes are now involved and the hours need to be checked. Okay, well, how long? So it is asking about the time factor, right? So 500 is equal to 4 into h. So the value of h is nothing but 125. How did I come to the conclusion? I quickly solved it. 5 into 100, 4 upon 4, 4 ones are 4 and 4 25s are 5 into 25 is 125. So 125 is my answer, or 2 hours and 5 minutes is my answer, right? Moving on. Now, there are times when a start time is given. When a start time is given, let's assume that um, there were three pipes A, B, and C. One was started at 10 p.m., the second was started at 11 p.m., and the third was started at 12 p.m. or 12 a.m. Okay, so 12 a.m. This is the night time when the pipes are running. So from 10 p.m. to 12 a.m., 2 hours A has already done the work. From 11 p.m. to 12 a.m., B has already done 1 hour of his work, right? But we start everything from 12 a.m., considering that A, B, and C are all working together, and the pipe or the entire situation started happening at 12 a.m. How does this help you? This helps you in this manner that you simply have to add the work already been done by A and the work already been done by B. Okay, the work already been done by A and the work already being done by B, and then you give all of them a start together. Okay, you make all of them work together. So this is what the concept calls out for, right? So I'll quickly take you to the question. Pipe A, B, and C can fill a tank in 20, 30, and 60 hours. Okay, one is 20, one is 30, and the last one is 60. This is A, this is B, this is C. Okay, pipe A, B, and C are opened at 7, 8, and 9 a.m. I've already talked about it. 7 a.m., 8 a.m., and 9 a.m. Okay, so when will the tank get full? What I'll do here first is that I'll use 20, 30, and 60 and quickly find out if there was no time barrier, what would their efficiencies be. When I talk about efficiencies, I also talk about what would their time, what would their contribution to filling the tank would be. Okay, so for that I'll quickly take the LCM of 20, 30, and 60, which is 60. For 20 the contribution is 3, for 30 the contribution is 2, for 60 the contribution is 1. So these are the efficiencies. This was the time, and the efficiency is also equal to the contribution each one of them is putting. So starting with the same timeline, there is 7 a.m., there is 8 a.m., and there is 9 a.m. If A was working over here, A and B were working over here, and A, B, and C were working over here, right? So if only we talk about A has already done 2 hours of work. Okay, A has already done 2 hours of work till 9 a.m. We put benchmark of the latest time. Okay, the latest time out of 7 a.m., 8 a.m., and 9 a.m. The most late, I should rather say, the most late is the 9 a.m. work. So at 9 a.m., everybody is working together. So I'll consider that to be my starting point. So A has already done 2 hours of work. The efficiency of A is 3. So 3 into 2, that means 6 units of work has already been done by A. B has already done 1 hour of work, which is equal to 2 units of work in 1 hour, which is equal to 2 units. So 8 units, 8 units of work was already done. When 8 units of work was already done, total work was 60 units. Okay, this 60 units, which was the LCM, is also equal to the total work. When the total work of 60 units was done, and 60 units was supposed to be done, and 8 units was already done, this means 52 units of work was left. This 52 units of work was done by A, B, and C together. A, B, and C together. The efficiency of A, B, and C when added up comes out to be 6. So 52 divided by 6 gives me 6 8s are 48, right? And 6 8s are 48, and 4 is left behind upon 6. This comes out to be 8 2 by 3. This comes out to be 8 2 by 3. Just give me a moment, I'll grab some more space. This comes out to be 8 2 by 3. So I have 2 hours of work which was already done by everybody, by A and B alone. Uh, no, not A and B alone, but A and B were functioning 2 hours before that as well. So 2 hours plus 8 2 by 3. This gives me my answer as 10 2 by 3. Okay. My final answer comes out to be 10 2 by 3. Right. Moving on. Two taps P and Q can fill a tank alone in 10 hours and 12 hours. If the two taps are opened at 9 a.m., at what time tank P or tap P should be closed to completely fill the tank at exactly 3 p.m.? So what we will assume that from 9 a.m. to 3 p.m., one of the two taps was working continuously. Okay, one of the two taps was working continuously. So which of them would be the case? I'll start with P and Q here. P can do it in 10 hours. Q can do it in 12 hours. If the two taps are opened at 9 a.m., right? I'm calling the shots at 9 a.m. That things are starting off at 9 a.m. Now till 3 p.m. How much time do I have? 3 hours till 12 p.m. and 3 hours till 3 p.m. So I have 6 hours time. Okay. So 10 and 12. The LCM comes out to be 60. 6 units of efficiency here and 5 units of efficiency here. For the this is the total work. This is the total work. These are the efficiencies and these are the times. Okay. These are the times. Now talking about 10, 12 and 60, the total work is 60. Q, which is the second tap, is working throughout. Okay, the second tap is working throughout. That means the second tap is open for 6 hours. For 6 hours, if 5 units of work would be continuously done, then 30 units of work, the 30 units of work would be finished off. Out of a total of 60 units of work, if 30 units of work is already finished off, I am left behind with 30 units of work. This 30 units of work was done by was done by P, was done by P as well, right? Was done by P alone. When P alone is doing 30 units of work and its efficiency is 6 units, at that time I can see that P alone can do his part of the job in 5 hours. P alone can do his part of the job in 5 hours. When 30 units of when 30 units of water has already been contributed by Q, only 30 units of water is left to be filled, right? This 30 units of water which is left to be filled or yet to be filled is being done only by P, is being done only by P. So it would take 5 hours to do the job. 5 hours from when? 9 a.m. plus 5 hours. So 9 a.m. plus 5 hours would give me 2 p.m. So 2 p.m. is my answer over here. Okay, I hope you get it. Moving on. Now, we've already done it in the past as well. We were assuming that A and B are working. A is working on the first day, B is working on the second day, A is then working on the third day, B is working on the fourth day, and so on and so forth. Okay, so I've taught you a trick how to manage this. So what you have to do is you have to consider that A is working on the first day, B is working on the second day. You have to assume that in 2 days, A plus B worked. Then you have to consider that 2 days is equal to 1 day. Okay, you have to consider that 2 days time is equal to 1 day's time. We've done it. I'll quickly do it one more time. You will be able to understand it much better. Okay, two pipes A and B can fill an empty tank in 10 hours and 16 hours respectively. They are opened alternatively from each Okay, they are opened alternately for them each. Okay, opening pipe is B first. So how many hours will it take for the tank to be filled? This is A, this is B. The efficiency is 10 and 16. The total work 16 fives are 80. So yeah, 80 is the total work. 8 is the work being done by them. 5 is the work being done by B. The total work is equal to 80. Okay, we have 80 as the total work. Now, uh, if I start with B, if I'm starting with B, then in the first hour I'm doing 5 units of work. Then in the next hour, A is working and he is doing 8 units of work. Okay, so together they are doing 13 units of work in 2 hours. 13 units of work in 2 hours. The total target is 80. I am doing 13 in 2 hours. Now, to bring it closer to 80, 13 6 are 78. I'll multiply 6 on both the sides. So in this is 6, okay? 6 on both the sides. So 78 units, 78 units of work would be done in 12 hours. In 12 hours. So if there is 78 units of work that needs to be done, only 2 units of work is left. And at that time, and at B, then A, B, again B would the picture. Again B would come into the picture. So this 2 units of work would be done by B. Okay, would be done by B. Coming one, doing it in one more step ahead. 12 hours was the work which was done, plus 2 units of work was left, and B's contribution was 2 by 5. Or I can simply say that 12 2 by 5 is my total time. 12 2 by 5 is my total time. Right? How did this 2.2 by 5 occur? This was the this was the work left. That is why 2 by 5 is the thing. And why 5 came here? 5 was the efficiency of B. Okay, 5 was the efficiency of B. Moving on to the next question. P alone can fill a tank in 18 hours. Q alone can fill the tank in 24 hours. Both the pipes are open alternate hours. Q is opened first. How much time will they take to completely fill the tank? Okay, I'll quickly do it without much explanation. This is P, this is Q. 24, 72 is the LCM, which is nothing but the total work. 18 4 is a 72 and 24 3 is a 72. Q is starting off at first, so Q is contributing 3, P is contributing 4. Both of them together are contributing 7 in 2 hours. Multiplying it by 10, 7 into 10 is 70 hours. Sorry, 7 into 10 is 70 units of work. 72 units is the total work, and 20 hours is the time. Okay, I'm multiplying it by 10. 20 hours is the time. Units of work over here. 70 units of work over here. 70 units of work, 10 hours. Now, if P, like after every alternate work, both of them were working together. So Q and P, Q and P. So once one cycle of Q and P is completed, the next one to start the work is going to be Q. So 2 units of work is left, and Q is involved in working it out. The efficiency of Q is 3, so 2 by 3 would be the answer. Combining both of them, we get 10 hours plus 2 by 3 hours. This gives me, no, not 10, but 20. 20 plus 2 by 3 hours. This is not 10, this is 20. 20 hours plus 2 by 3 hours. This gives me 62 by 3 hours as my final answer. Okay, I hope you're able to understand what I have taught over here. You may read the question, you may pause the video and read it one more time. Yep. Moving on. Yeah. So we've already talked about this concept. I'll quickly take you to the question straight away. Okay. A can fill a tank. A can fill a tank in 16 minutes. B can empty the tank in 24 minutes. They are working together. After how much time should B be closed so the tank is filled in 30 minutes? Okay. How much time should B be closed to fill the tank in 30 minutes? I have A over here and I have B over here. A is doing the job in 16 plus and B is destroying the job in 24 minus 16 and 24. 16 3s are 48. Yeah. So 48 would be the LCM. Total work is 48. 2 units of work, no, 3 units of work is done by B and 2 units of work is being destroyed by B. Okay. 3 units of work was being done by A and 2 units of work was being destroyed by B. If 30 minutes is the total time, if 30 minutes is the total time, that means that A was working full and B was working part. A was working full and B was working part, because it is said that B is supposed to be closed somewhere in the middle. B is supposed to be closed somewhere in the middle. So A was working on full throttle. Let's assume 30 minutes is the total work, is the total time that was taken. And for 30 minutes, A was working full with a 3 plus efficiency. Had that been the case, 90 units of work would have been completed. But the capacity of the tank is 48 hours, or 48 is the total work or the total unit of work which has to be done. So if 48 is the total unit and 90 units of work was done, that means 90 minus 48, which is equal to 42. 42 units of work is a waste. 42 units of work is a waste. This is true. Okay, 42 units of work is a waste. So what do we actually do about it? This 42 units of work was destroyed by pipe B. Okay, this 42 units of work was destroyed by pipe B. And how did it destroy it? It destroyed it with the power of 2 negative efficiency. Okay, so this is nothing but B's destruction. B's destruction of work, 42 upon 2, which gives me 21 minutes. So B is supposed to be closed after 21 minutes so as to allow the entire work to be completed in 30 minutes. Got it? Got it? This work was done by A, A alone. Okay, this work was done by A alone, and this destruction was done by B alone. Okay, I understand that both of them were working simultaneously. I understand that both of them were working simultaneously, but we have a position where we can separate both of their works. Okay, we can separate both of their works. Moving on. Okay, the question says an inlet pipe can fill an empty tank in 3.6 hours, while an outlet pipe can drain a completely filled tank in 6.3 hours. If both the pipes are opened simultaneously when the tank is empty, how many hours will the tank get completely filled in? Okay, or in how many hours will the tank get completely filled? The inlet pipe, let's assume that A is the inlet and B is the outlet. 3.6 hours of positive work is being done here and 6.3 hours of negative work is being done here. 36 and 63. The only issue that will come here is 9 into 4 into 7. Okay, this is the LCM. This is the most tough part of the entire question, that 9 into 4 into 7 is the LCM. 9 4 is 36, so 7 is the positive efficiency, and 9 into 7 is 63, so 4 is the negative efficiency. Okay, 7 is the positive efficiency and 4 is the positive efficiency minus 4, which is the negative efficiency. This is 3 3 is a 9, 7 4 is a 28, or 7 3 is a 21. 21 into 4 is is 84, okay, or 84 rather, I should say 8.4. So 8.4 hours is the time that it would take to completely fill the tank, right? This is my fourth option. I hope we are good. Moving on. Now, when more than one pipe is filling and another is emptying, similar thing. You just need to multiply the number of pipes with the efficiency that they are doing the work with. Okay. So A and B are working for, are filling the tank in 432 and 108, in 432 and 108, and C is doing it at 3 liters a minute, and all of them are doing it together in 54 minutes. So what I'll quickly do is I'll form this equation. AB and ABC. A is doing it 43.2, B is doing it in 108, and C is doing it in 54. Now we have all the figures over here. I'll quickly need to go to the point where I have the LCM. Out of this, 432 is the biggest number and it is divisible by everybody, by 108 and 54 as well. So I'll consider that 432 is my LCM. For 432, for A, 10 units of positive work. For 10A, 4 units of positive work. And for A, B, and C together, 8 units of positive work. Okay. So these units are nothing but efficiencies. Efficiencies. There's no water. No problem. No problem. Okay. So these are efficiencies and this is the total work and this was the time which was being taken by all of them. If A's capacity is 10 and B's capacity is 4, the capacity of A plus B would be 14, and when A, B and C is introduced, the capacity comes out to be 8 units of work together. So this means that C is doing a negative job and that C's job is equal to 6 negative. Okay, C's job is 6 negative. Now, let's assume that 432 was the total work being done and only C was doing the emptying work. Okay, only C was doing the emptying work. Why am I using only C? Because I know that C can work alone and give me 3 liters of water empty, or 3 liters of water would be pouring out of C. So if I use the total work divided by the efficiency of C and then multiplied by 3 liters, that is how I would know the total capacity of the tank. So if total work is 432 and the efficiency of C is 6, this can give me the time of C. 432 by 6, 432 by 6 is 6 sevens are 42 and 6 twos are 12. So 72 minutes is the time of C. C would take 72 minutes to empty the tank. Once I have this data that C would take 72 minutes to empty the entire tank, all I need to do is multiply it by 3 liters per minute. 3 liters per minute. So 72 into 3, this gives me 3 to the 6 and 3 sevens are 21. So 216 liters is the total capacity of the full tank. Okay. I hope you understood. I hope you understood. Moving on. Right. This is my last question. And this is going to be a little big. Okay. This is going to be a little big. The question says that 2 pipes can fill a cistern in 12 hours and 16 hours respectively. 12 hours and 16 hours respectively. They both are opened simultaneously and it is found that due to a leakage at the bottom, it takes 90 minutes more to fill the cistern. How much time will the leakage take to empty the entire cistern? I'll take it step by step. Talking about A and B, they are working together. A is doing it in 12 hours, B is doing it in 16 hours. Together, they will do 48 units of work. The input done by A would be 4, and the input done by B would be 6. These are the efficiencies. 48 is the total work, and these are the times. If I need to find out how much time are A and B taking together, they are using 7 units of work, or they are doing 7 units of work in 1 hour. So if 48 work needs to be done and 7 units of work is being done by them in 1 hour, so A and B's time would be 48 upon 7. A and B's time would be nothing but 48 upon 7, right? So I am through. I am completely through. 48 upon 7. The question says that it takes 90 minutes more, and 48 upon 7 is in hours. It's in hours. So 48 upon 7, and 90 minutes extra is taken when C is also open. C is the leakage. So A, B, and C together would take 48 upon 7 plus 90 minutes. For 90 minutes, I would be writing it as 90 upon 60, okay, which is nothing but 3 twos are and 3 threes are. So this would gives me 3 upon 2 hours more. 48 into 2 is 96. 96 plus 21. 96 plus 21 is 117. Yeah. 96 plus 21 is 117. So 117 upon 14. 117 upon 14 is the total time. Okay. This total time of all A, B, and C. A being positive work, B being positive work, and C being negative work. Right? How much time will the leakage take to completely empty the tank? To completely empty the tank. Now, I'll need a little more space. When A and B are working together, 48 upon 7 is the time they are taking together. When A, B, and C are working together, 117 upon 14 is the time that they are taking to work together. Now, I need to find out a point. I need to find out a point which is common so as to get the LCM in place. So as to get the LCM in place. Okay. So what is the LCM over here? The LCM is nothing but 13 into 9. 13 into 9 is 117, right? 13 nines are 117. Now 48 needs to be accommodated. I will not be focusing much on the denominators. I won't be focusing much on the denominators. 13 into 9 is 117. Now 48 needs to be accommodated. If I use 3, 16 threes are 48. So 16 would be multiplied here. So 13 into 9 into 16 is my LCM. This is the total work. I need to work out with C alone. Okay, so that is why I have to take the LCM. If 13 into 9 into 16 is the total work, and then I need to find out how much did A and B do. So 48 upon 7 would be checked. 16 threes are 48, 3 threes are 9. So 21 into C together's efficiency, or together's time, that is 117 into 14. 13 nines are 117. This entire thing gets chopped off. So 16 into 14, right? So 21 into 3 13. I'll quickly do it. 13 ones are 13, 13 twos are 26, 273, right? And 16 into 14, 16 fours are 64, 6 in carry, 16 ones are 16, 22. Okay. So when two people are working together, they are putting in 273 of efficiency. When three people are working together, they are putting 224 of efficiency. So there is a difference of efficiencies. That means this would come out to be as 6 and this would come out to be as 49. So this means that 49 which has come out is C's negative contribution, because it is pouring things out. Okay, it was pouring things out. Now again, the total work is 13. The total work is 13 into 9 into 16. This is the total work. And talking about C's efficiency, C's efficiency is nothing but 49. So this would give me the time that C would alone take to fill the tank. C would alone take to fill the tank. Now, do all the options have 49 in the bottom? The answer is yes. So I'll quickly have to multiply all of it together. Okay, 13 6 is 78, 7 in carry, 13 1 is 7. This is 208, 208 into 9. 9 8 is 72 and 9 2 is 18. So 1872 divided by 49. Okay, I'll do 49 divided by 1872. 49 3 is a, right? 49 3 is a, do I have anything starting with 3? I have everything starting with 3. Okay, 3 9s are 27, 3 4s are 12, 12 plus 2, this is 147. This would give me a 0 and this would give me a 402. This would go at 9. Yep, this would go at 9. 9 9s are 81, 9 4s are 36. No, not at 9. 490. This would go at 8. Okay, 8 9s are 72, 7 and 9 8 4s are 32, 32 plus 7 392. So we have 10 units of work which is left. So this means my final answer would come out to be 38, 10 was the remainder and 49 is the denominator. So 38, 10 by 49, which is my option number D. Okay, my option number D. This is my final answer. I would explain it to you one more time. I'll quickly explain it to you one more time. Just try to look at things my way. The total work which was done by A is 12, by B is 16. They together complete 48 units of work in 4 plus 3, 7 hours. That means 48 upon 7 would be A and B's time together. Then a leakage developed which took 90 minutes extra. This is nothing but 90 minutes extra. This 90 minutes extra was added up with the total time, which brings me a total time of 117 upon 14 for all A, B, and C, where A is doing a positive work, B is also doing a positive work, and C is doing a negative work. Okay. So once I have it all, I will have to do this process again. This is the new total work which is supposed to be done between AB and ABC, right? This output is only that of AB and this output is that of A, B and C together. So from this I can see that C is doing a negative work. Why? Because when three of them are working, they are producing lesser efficiency as compared to when two of them were working. Okay, because 224 is lesser than 237, 273. That is why this is the gap that is coming up. So what do I do with that? I have total work available with me with C's efficiency under it. This would give me nothing but C's time. Okay, this would give me nothing but C's time. What did I come to the conclusion with? This was 208 multiplied by 9, which is 1872, right? 1872 upon 49. This is C's time, and my final answer came out to be 38, 10 by 49. So this was not much different from whatever we have done. This was not much different from whatever we have done in the past. The only gap or the only point which needs to be sorted, I'll just show you whatever is written over here. Okay, A is positive, B is a little negative, and C is also here, right? A is positive, B is positive, and C is negative. So the only thing that was supposed to be done, I'll quickly take you to the next page as well. I think you might not have seen whatever is done in the next page. Yeah, next page is here. Next page, this is C's time and B's time. I did not write much on the right margin, so you won't find it very difficult to find the answer. Okay, there is some portion that is left behind here as well. Yeah, so this is the portion which was left behind here. Okay, I hope it is pretty clear to everybody. Okay, so thank you so much. Pipes and cisterns is also over and complete. If you have any doubts, any questions, please drop your comments and we'll cater to them. Thank you.